0.01 m solution of a weak base BOH in water, मतलब सॉल्वेंट हो गया वाटर और इसका वेपर प्रेशर है, इस सॉल्यूशन का वेपर प्रेशर है 17.536 मिलीमीटर ऑफ मरकरी। Kb फॉर द बेस कैलकुलेट करना है। एक्वस टेंशन एट 20 डिग्री सेंटीग्रेड गिवन है 17.54 millimeter of mercury. Aqueous tension means vapor pressure of pure water and this is given as 17.54 millimeter of mercury. बेस की डिसोसिएशन के लिए इक्वेशन हो जाएगी BOH डिसोसिएटिंग इनटू B प्लस एंड OH माइनस आयंस। इनिशियली मोल्स ऑफ बेस जो प्रेजेंट है लेट इट बी 1 मोल and number of moles of B plus and OH minus ions is 0. Now when BOH dissociates to give B plus and OH minus ions, then out of 1 mole if alpha moles dissociate, then remaining BOH in the solution is 1 minus alpha moles. Moles of B plus ions हो गया alpha and moles of OH minus ions हो गया alpha. Now value of I is equal to number of moles after dissociation, which is equal to 1 minus alpha plus alpha and this is equal to 1 plus alpha divided by number of moles before dissociation. Now number of moles before dissociation है 1. So value of I becomes 1 plus alpha divided by 1. Let this be equation number 1. The value of I is also equal to observed lowering in vapor pressure divided by calculated lowering in vapor pressure. Now observed lowering in vapor pressure will be equal to vapor pressure of the pure solvent, that is water, and it is 17.540 millimeters of mercury, minus vapor pressure of the solution, which is given as 17.536 millimeters of mercury, and its value is equal to 0.004 millimeters of mercury. Now calculated lowering in vapor pressure. Calculated lowering in vapor pressure, for that we will apply the formula relative lowering in vapor pressure is equal to mole fraction of solute. Now relative lowering in vapor pressure is vapor pressure of pure solvent minus vapor pressure of solution divided by vapor pressure of pure solvent, and this is equal to mole fraction of solute. Now mole fraction of solute is equal to moles of solute divided by total number of moles. Now the molality of the solution is given as 0.01 m. 0.01 m means 0.01 moles of solute is present in 1 kg of solvent. Since the number of moles of solute is very less, we can neglect the moles of solute in the denominator. So P naught minus P divided by P naught becomes equal to moles of solute divided by moles of solvent. From this, P naught minus P, that is calculated lowering in vapor pressure, is equal to moles of solute divided by moles of solvent into vapor pressure of pure solvent. Now putting the values, moles of solute is 0.01 moles. Moles of solvent will be equal to weight of solvent, that is 1000 grams. 1 kg is equal to 1000 grams divided by molecular weight of solvent, that is 18 since the solvent is water, into P naught. P naught is given as 17.54, which is the vapor pressure of pure solvent, which in this case is water. Solving, the calculated lowering in vapor pressure is equal to 0.00316 millimeters of mercury. So value of I becomes equal to 1 plus alpha divided by 1, which is also equal to 0.004 divided by 0.00316, and this is equal to 1.266. From this, 1 plus alpha is equal to 1.266 and alpha is equal to 0.266. Alpha will be equal to 1.266 minus 1, that is 0.266. Kb is equal to concentration of B plus ions into concentration of OH minus ions divided by concentration of remaining BOH. Now, when the initial concentration of BOH was 1 mole, then out of 1 mole alpha moles dissociated and concentration of B plus ions was alpha moles, OH minus ions was alpha moles, and the concentration of remaining BOH was 1 minus alpha moles. But in the question it is given that the initial concentration of BOH is 0.01 m, which means the number of moles of BOH present in the solution is 0.01 moles. So when the initial concentration of BOH is 1 mole, the concentration of B plus and OH minus ions is alpha moles, and when the initial concentration of BOH is 0.01 moles, then the concentration of B plus ions will be 0.01 into alpha, OH minus ions will be 0.01 into alpha, and the remaining BOH will be 0.01 into 1 minus alpha. Now value of Kb is equal to B plus ion concentration into OH minus ion concentration divided by concentration of remaining BOH. So putting the values, we get 0.01 into alpha into 0.01 into alpha divided by 0.01 into 1 minus alpha. Solving, the value of Kb is equal to alpha square into 0.01 divided by 1 minus alpha. Now putting the value of alpha and solving, the value of Kb is 9.6 into 10 to the power minus 4.